Hello everyone. I'm starting with this old wall clock that unfortunately isn't working anymore. I'm going to turn it over to reveal the battery compartment. I'm taking out the AA battery inside. This battery is old and clearly not working. Nothing happens when I clap to check if there's any movement. It definitely isn't powering the watch, so I'll take it apart again. I will use another battery to check if the watch is not working because the battery is dead or the watch is broken. Luckily, my watch worked again. It was just a dead battery. Let's see if we can bring this clock, and more importantly, its batteries, back from the dead. I'm using a multimeter to check their voltage. I'm setting my multimeter to the continuity test. This helps me ensure the probes are working correctly, indicated by the OL changing to 000 and a beep. Then I switch it to DC voltage mode, specifically the 20V range, as these are small batteries. Let's test one of these seemingly dead batteries. I connect the red probe to the positive terminal and the black probe to the negative. As you can see, it reads around 1.64 volts. This is what a working battery should show. Now, let's retest the old battery to confirm its state. The voltage fluctuates and then drops, confirming it's essentially useless. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. The first step in our process is to gently scrape the positive terminal of the batteries using a utility knife. I'm being careful here, just trying to remove any oxidized layer or coating that might prevent good contact. This exposes fresh metal, which is essential for the upcoming chemical reaction. Similarly, I repeated scraping the other negative terminal of the battery. It looked cleaner and conducted electricity much better. This small preparation made a big difference in the efficiency of the battery charging method. You can actually feel the slight change in texture. Next, I'm taking a roll of aluminum foil and cutting off a manageable piece with some scissors. Then, I will tear this piece into many small pieces. The goal here is to create many small pieces, which will increase the surface area for the reaction we're about to create. I will squeeze the pieces of aluminum foil into these small circles and drop them into the glass. These will act as one of our key components. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. For our next step, I'm using an electric kettle to heat some water. Hot water helps accelerate the chemical process we're aiming for. I'm adding water to the kettle, placing it on its base, and switching it on. You can already see the water heating up, which is exactly what we need. Now that the water is hot, I'm carefully pouring it into the glass containing our crumbled aluminum foil. This hot water will serve as the solvent for our electrolytic solution. To make our solution conductive, I'm adding a spoon of common table salt to the hot water and aluminum foil mixture. The salt dissolves, creating an electrolyte that allows for the flow of ions, which is vital for recharging. I'll stir it well to ensure the salt is fully dissolved. I'm carefully placing the scraped battery into the salt solution with the aluminum foil. You can immediately see a reaction happening. Bubbles are forming around the battery and the aluminum foil. The water is starting to change color, indicating the chemical process is underway. The aluminum is reacting with the salt and water, generating hydrogen gas and helping to clean the battery terminals and potentially re-energize the battery's internal chemistry. I'll let it sit and work its magic. After a while, you can see how much of the battery's outer coating has come off, and the water has changed significantly. Now, I'm taking the battery out and wiping it clean with a paper towel. Let's retest the battery with the multimeter. And look at that. It's showing around 1.40 volts. That's a significant increase from our initial reading of 0.00 volts. This simple trick has successfully recharged our dead battery. Now, let's put our recharged battery back into the clock. I'll reinsert it into the battery compartment. And there you have it. The clock is ticking perfectly again. Both the minute and second hands are moving smoothly. This proves that even old, seemingly dead batteries can be revived with a bit of ingenuity and a simple chemical solution. This incredible DIY hack can save you money and reduce waste. Don't forget to subscribe for more fantastic DIY ideas. Thank you for watching, and I'll see you in the next one.